The Impulse-Momentum Theorem explained in 60 seconds or less. Let's say a snowball is rolling down a snowy hill and it's getting larger and faster. We would normally say that the snowball has gained momentum, even though we might not know what that means. Let's break it down. In this situation, we see that the snowball has gained both velocity and mass from its starting position, and this is how we define momentum. Now let's change the situation and say that you are running down this hill. Intuitively, you'd know that you have a much faster final velocity if you start at the top of the hill rather than in the middle, and as such, have a much higher momentum in case 1 than in case 2. Now imagine that you have to stop running, meaning you'd have a final velocity of 0 and therefore a final momentum of 0. In case 1, you'd find it a lot harder to stop yourself than in case 2, simply because you have a much higher momentum. As such, we arrive to the first glimpse of the theorem, looking kinda like this. But what if we switch up the situation to now have two cars, both traveling at 50 km per hour, and eventually having to come to a complete stop, but only one car is allowed to apply the brakes? We observe that both cars have the exact same change in momentum, but different forces being applied to the wheels. This breaks down our initial equation, but if we use intuition, we know that the car that relies only on the friction between the tires and the road will take a lot longer to stop than the car that slammed the brakes. So here, we must introduce a time dependence to get our final equation. And with that, this was